There's a scientist in China who's planning something so wild, so daring, that most people would call it impossible. His name is Cosmo Bambi, and he wants to send a tiny spacecraft, no bigger than a paperclip, on a race across the stars to a black hole. Not in a movie, not in some distant future, hundreds of years from now. He thinks it could happen in our lifetime. It starts with a challenge that's almost poetic. Black holes are the most mysterious objects in the universe, and yet we've never been able to truly see what happens at their edge. That invisible boundary is called the event horizon, the point where space and time twist so much that nothing, not even light, can escape. Einstein predicted it, but no one has ever confirmed it directly. It's like having a locked door in the middle of the universe, and we've been standing outside for over a century, wondering what's inside. Bambi's plan is to knock on that door. But instead of a giant rocket blasting off like in a NASA launch, his probe would be smaller than your fingernail. Inside would be sensors, a computer chip, and a shiny, ultra-thin sail. And here's the twist: no fuel. Instead, a massive laser array on Earth would fire a beam straight at that sail, pushing it forward. Photons, the particles of light, would slam into it over and over, accelerating it until it's flying at 1/3 the speed of light. At that pace, you could get from Earth to the Moon in under 2 seconds. In this mission, 2 of these paperclip spacecraft would travel together. When they reach the black hole, one would hang back at a safe distance while the other dives straight towards it. If Einstein is right, the falling probe signal will slowly stretch into longer and longer wavelengths, fading away until it disappears entirely. But if the fuzzball idea is right, the signal might just blink out, suddenly. No slow goodbye, no fade. That difference could rewrite the laws of physics we've believed for over a century. But here's the problem. We don't know if there's a black hole close enough to reach. The closest one we've confirmed, called Gaia BH1, is over 1,500 light-years away. Way too far for this mission. But based on how stars live and die, scientists think there could be one hiding just 20 or 25 light-years away. The trouble is, black holes don't shine. They're invisible. The only way to find them is to watch how they pull on nearby stars or bend light from far away. New techniques are improving, and Bambi thinks we could discover one in the next 10 years. That's the clock ticking. If we find it soon, we can start building. Building this mission won't be cheap. Today, the massive laser array needed to push the spacecraft would cost over $1 trillion. But technology gets cheaper. In 30 years, the price could drop to something space agencies might actually afford, maybe €1 billion. That's still a lot, but it's in the same league as the most ambitious space projects we already do.
The bigger challenge is surviving the journey. Space is not a friendly place for tiny machines. Micrometeoroids, cosmic rays, and dust grains moving at 1/3 the speed of light could tear a craft to pieces. It will take years of engineering just to give these little travelers a fighting chance. Still, think about what's at stake. For all of human history, black holes have been shadows in our imagination. We've seen their effects, even taken blurry pictures of their outlines. But we've never been close. We've never sent an explorer into their territory. This mission could be the first time we test, in person, whether Einstein was right in the most extreme environment possible. It could be the first time we see what really happens at the edge of forever. But here's the truth. We might not live to see the end of it. This mission will take nearly a century from launch to the moment its data arrives. It's a gift we'd send into the future, for people we'll never meet. That's what makes it both humbling and exciting. Somewhere out there, maybe only a few dozen light years away, a black hole is waiting. Silent, invisible, pulling everything nearby into its grasp. One day, a tiny ship, no bigger than a paperclip, could arrive at its doorstep, carrying our curiosity, our questions, and our hope. And when the answers finally come back, they might change everything we thought we knew about the universe.
If you want to be part of the generation that makes sure this mission gets built, that pushes humanity to the edge of knowledge, start by staying curious.